Apologies for the delay. In this talk, I'm going to talk about parametric type design. I will start with a very brief short self-introduction. I am a typeface designer and a software engineer. I had designed multiple fonts. Most of them are primarily Malayalam script fonts, but I also design Latin counterparts for these fonts. The first two fonts listed here, Manjari and Chilenga, they were designed a few years back. They were designed by manually drawing the leaves. The last two, Nopuram and Malini, they are variable and color fonts. And in the next 20 minutes, I'm going to talk about the technology used behind these fonts, which is MetaFont. These fonts, all of these fonts are free and open source fonts. So let me quickly go to the introduction. So Professor Donald Knuth, back in 1970s, developed a system to design typefaces called Metafont. The Metafont system followed mathematical approach to define curves and shapes in the glyphs of a typeface. Every drawing, every curve, or every line, everything was defined using mathematical geometrical equations in the Cartesian space. And he used this technology for designing famous fonts like Computer Modern, also Amos Euler. So he worked with Hermann Saff to design these fonts. However, this legacy technology, the Metafont technology, was not that successful beyond those fonts. According to Donald Knuth himself, asking an artist to become enough of a mathematician to understand how to write a font with 60 parameters is too much. Because at that time, type design was not considered as something like a technical or engineering oriented skills. But times has changed. If you look at the current day typeface design, typefaces are sophisticated software. It is getting increasingly becoming sophisticated as every year goes. With the introduction of the variable and color fonts, often a typeface designer need to work with a type engineer to produce a functional typeface. Either the designer need to possess a working knowledge of the software engineering and a little bit of mathematical skills to produce a high quality typeface, or they need to collaborate closely with a type engineer. This was the same case with Ronald Knuth also when designing Computer Modern and Amos Euler. He was working with Hermann Saff at that point of time. So in my introduction, I said I am a typeface designer as well as an engineer. So I try to see how good we can how we can use this technology, even though it is legacy and more than 50 years old, and how that can be modernized to make it fit into the modern typeface workflow. Mostly I was targeting variable and color fonts, which is the latest technology. Variable color fonts became a standard in 2016. Color fonts became a standard in 2020. So one of there were a few missing pieces in the MetaFont, which was later fixed by a variant of MetaFont called MetaPost. It's the successor of MetaFont. MetaPost was written by John Hobby, a student of Donald Knuth. One of the advantage of MetaPost was it outputs vector graphic, that is SVG files, while MetaFont was outputting bitmap images. So I took the MetaPost and I tried to see how I can use it. So in the next session, I will explain my approach, the modernization approach. I will quickly go through some ideas about what I meant by parametric design for those who are not familiar with the parametric design. And then I will explain how I use that parametric type design in my typeface design workflow. So to start with, let me show you a quick example. Here you're seeing an arc. This is a letter called Malayalam letter Ra, but you can just consider it as an arc. For the time it is an arc. And it is drawn using a pen defined here in this code. And that pen is an ellipse here. with the 40 as the major axis and 10 unit as the minor axis. But if I change the axis as same, I'm getting a circular nib, and you can quickly see that the shape of the letter change immediately. I can change the contrast into any value, and you can quickly see that the values are changing. So by changing just a few parameters, so for example, here I'm using height and width of this cliff as same as 500 units. What happens if I change the height into some 300 units? So it becomes like this. And if I change to something like a 600, it becomes like this. So this is a quick example of like controlling the parameters and a few geometric equations. You quickly get various shapes, but this shape is not useful in typeface design because this is just a skeleton. In typeface design, you usually need outlines. So outlines are not just a skeleton. Outlines by I mean it need the both sides of the drawing. So here is an example which uses the outline. Instead of just using a circle, I am defining a custom pen. Here it is a calligraphy pen. Calligraphy pen I'm using it is like a razor pen. It's a by razor pen, it's like a line with a certain width rotated by an angle here defined as 45 degree. So you can see that whatever you are seeing as the bottom of this start of this arc, that is the pen shape. And if I move that calligraphic pen with a razor shape, we are assuming that the size is 0. Physically, that's not possible, but assume it's like a narrow width pen. And we move that on top of the skeleton, this arc-shaped skeleton, you get this shape. And at this point, this vector image is immediately usable in a typeface, in the modern day typeface, because SVGs are easily converted into a glyph format, and you can use it in a UFO format. Because this is parametric, I can change the pen angle to any degree. So for example, I'm changing it to 30 degree here. You can see that the shape changed. I can change it to 60 degree. So it's the angle of holding that calligraphic pen. Usually in calligraphic design, as you know, you will hold the pen without changing the angle of holding. So if it here it is 60 degree, holding constantly, not changing the pen direction, you move on top of the skeleton, you get that shape. And you can change any of these parameters. So for the purpose of my typeface, the typeface that I designed for, that's called the Nopuram, which is inspired by the early Malayalam movie posters by 1960s. I wanted a little bit more complicated type modulation. It's not just one nib. I need multiple nibs. So here you can see that it starts with a somewhat thin and then thick, then thin, thick, that kind of alternate modulations. This was not possible in MetaPost. This required a little bit more sophisticated nib definition, and I used a set of macros that is imported here, which was designed as part of a project called MetaType. And with that, I'm changing whenever I am moving my nib on top of the skeleton, I am picking different nibs. So here I pick the thin nib, and here I pick the thicker nib, and then thin, thick, etc. So I change this one. And that thick and thin is based on a contrast ratio. Here it is 0.75, that's the contrast. But I can change to 1.5, for example, here, and you can see that the full contrast ratio change. And it's in a kind of a reverse contrast ratio now. And I can go back to 0.5, then it becomes in a completely different contrast ratio. So by changing these kinds of parameters, you can go with any kind of parameters, and this kind of MetaPost paradigm of writing geometrical equations, you can get these kinds of glyph drawing. It is to be noticed that when Ronald Knuth was designing AMS Euler or computer modern back in 1970s or 1980s, early 1980s, um, uh, the process was not that quick. There was a huge delay between writing this program that you are seeing on the left side of the screen and getting the shape on the right side, because at that point of time he had to program it first, put it into punch cards, and then run it on the mainframes. That was the process that followed at that point of time. So you need to be very accurate in your mathematical equations, make sure it's work in theory, and then work it. But here I built a tool, not really a tool, but basically I can compile instantaneously when I change the source code, right? So here I can change this and I can quickly get the output like I was demoing. So this makes the experimentation very easy. The feedback loop is very tight. So it's just like you are dragging a QBR Bezier handle in your GUI design and you see the output. So it's quick. There is milliseconds of delay between what you code and what you see in the output. So one of the criticism for this kind of approach is that I used a skeleton here, right? And then I used a pen on top of that skeleton. This is hardly the approach that we use in the typeface design these days. We design outlines, not the skeleton these days. You will start with this outline only and not really care about the skeleton. And you also need to account for various optical corrections because the aim is not to make the mathematics accurate. The aim is to make it pleasant to your eyes and the eyes of the readers. So because of the modularity and the immediate feedback cycle, and since this is basically Cartesian mathematics, it's not that impossible to work completely on the outline, not on the skeleton. To illustrate that, let's take another example where I completely worked on the outline without going through the skeleton approach. So here I used the same equations. I did not use a nib, but I used some kind of concept that the stem width is going to be this much and it is going to be narrow, that kind of contrast ratio. And you can also work with this kind of thing. Why I'm saying this is that usually when you work with a typeface, most of the time you will require a mixed approach. You will need both skeleton and also outline based approach if you want to get the shape that is according to your design. So if you look at a very sophisticated design like this, which is a flourish design of a letter called Sa, it's like the first letter of my name actually. So here I'm using both approaches, and I'm using kind of a repeated code and modularity for this kind of a leaf or like a floral decorations. You need both skeleton based approach and the um, outline based approach you will require for this kind of thing. And you can also think about this as kind of a serif if you're designing some Latin font. So that can also not be designed using a calligraphic name, right? Serifs are usually done using some special handling of the calligraphic nib or some pressure modulation, etc. So you need both approaches, and I'm here illustrating that you can do both. But whether it is easier than the GUI based design or whether this is easier, it depends. I will come to that point at the end of the talk. So I will now explain the whole workflow, how I compile this MetaPost source code into a working typeface. So here I have a MP files, those are MetaPost source codes. And then I will compile that MetaPost, and MetaPost will create SVG files. And then SVG files, you can convert that into a glyph file. It's not easily convertible. You need to write some program because the Cartesian system that is used in the axis system, XY axis system that is used in the SVG, not exactly same as that is used in a glyph format. It's upside down. And then you can create this glyph, and if you combine all these glyph files, you get a UFO file, and then you create open type features, which is pretty much important for the script that I was targeting. Malayalam is a complex script. You combine the open type features into the UFO file, you combine it, you get the output, the TTF or OTF. And I was saying that by controlling the parameters, you get different SVGs. I showed how changing a nib width or some parameters, you get variable fonts, right? So what you are getting is variable fonts. So this was a concept that Donald Knuth introduced back in 1970s, but at that point of time, the idea of variable font was not that there, but the concept, undeniably the concept set by Donald Knuth lived, and now we have variable fonts, right? So let me show you the results of the whole process as the typefaces that I built by using the same workflow. So here I have this typeface. the output typeface. This is a font editor called the Fondra, and I'm using the first letter of Malayalam here, A, and it has 4 variable axes. The weight axis, you can see it's smoothly interpolating. This is result of multiple masters I created using the parametric type design. So here you can see all the other variations created, and it's interpolating between all of these things when I move this slider of the weight axis. Similarly, you can also have the width axis. You can also have the slant axis because it's slant. You need to have that oblique. It's not italic. There is no concept of italic in the script that I targeted. You can also have an additional axis called the soft, which is the softness of the terminals. You can see the terminals becoming soft or sharp based on this axis. So with this kinds of glyphs and this interpolation, you will get a shape, a font like this, and I'm going to demonstrate it in a web page. So here you have this, all of these things, and I can change using CSS. That's the variable typeface, right? You can change using CSS the weight and the extreme weight or minimum weight. All of these things you can change. You can change the slant. So not only English, but I also designed the Latin counterpart for this one, matching with the Malayalam typeface. So you will get this kinds of design. So let me switch back into, yep. So once I designed this variable font, I had an idea that I can create another subfamily by just changing the nib, right? So what if I change the nib into a calligraphy font? So you will get a calligraphy font like this. With the same design, you just changed, you get a completely different font like this. And it is again variable typeface into the calligraphic nib. So with the single master design, I created a new typeface by just changing the nib with the same source code. So this became a calligraphy based typeface design. But when I got this, I had a crazy idea. If I combine the calligraphic nib and the regular nib and layer one top of another, you will get a very interesting 3D pattern. So let me show you that like this. So here, if I color that layers based on the color font technology that came in 2020, you get a color font. So here you are seeing a font, not a graphic design, not an SVG image. This is a real font. This is the new technology called the color fonts, where you can change. Let me show you some other examples. Yeah, you can also have English. Yeah. Right. So if you look at closely, you can see that it is 2 fonts layered on top. The calligraphy version at the bottom layer, and the other font, the first font that I designed on top of it. And if I do a kind of a clever coloring, I get this kind of a 3D coloring. And the color fonts also supports palettes. It comes with a predefined color palettes. So these are like, you can change the color palettes in CSS like this. And I added like 18 predefined color palettes. The color fonts are also customizable like CSS, so you can change the colors. So for example, you can change the colors at the runtime. So you can use a color picker. It's all functioning in a web page. You can change the colors as you required. Color fonts are also variable fonts, so you can change the weight or also called as like the shadow. So you can go increase the height, the height of the shadow like this. So this is again another typeface I created from the same design, but varying the glyphs and using that abstractions. When I worked on this one, I had another idea. For a second, yeah. Let me go back to this one. Okay, right. So instead of layering 2 things, what if I draw arrow shapes on top of the letters? Then I can show how a letter is written. And this has educational use, right? Because I can use this for kids to teach how to write a letter, because you can see that it has arrows that follows the direction. And if I use the base layer as a color and the top layer as another color, you can see it's an arrow font. You can use it in educational context. But since this is like a programming, I can change the arrows and change into something else. So I tried putting it as dots. Here it is. Yeah, here it is. I drew dots on top of the shapes. Instead of using a nib, I put dots. So this means you can use trace the letters and learn how to draw it. So these are all derivatives I created on top of the same font, which were all possible because of this, because of the approach. So Donald Knuth had warned against creating too many fonts if you follow this approach, and he said doing too many fonts may not be the right approach. However, this was the first font that I tried with this approach, so I just wanted to see the limits and possibilities of the approach. So that's why I followed and created these five type families. And this is not this designing this typeface was easy because it's like a more or less like a handwriting, not like a strict shapes. But I wanted to take a challenge and see whether I can really create a modular body typeface with the same approach. So that's the second font that I designed. So here you can see a typeface which has both Latin and Malayalam, and which has 4 axes. By the way, the color font that I designed, it was the first one of the first color fonts in actually in Indian languages, the first color font in my language, because I tried immediately when that became a standard. So this has 4 axes, the weight, width, slant, and also the optical axis. So this is something that I wanted to try for a long time, but could not do that because of the effort it required. But with this technology, I could try the first optical axis font for my script. So yeah, the weight and width is explainable, how it is interpolating. In optical size axis, I tried to reduce the contrast and also some the width and also the left and right bearing, which is not really visible here, but you can see the contrast changing based on the axis change. But you don't need to change the axis in usual web pages. Based on the font size, the axis will be picked up. So the result was this typeface. Let me increase that one. So this is a body font, also has Latin in it. Like I said, I'm not really a Latin typeface. I'm targeting this for Malayalam, but I tried my best effort for designing a Latin typeface also, because it requires a counterpart when you design a full font, right? Which also has this axis, weight axis, and the width axis, also the slant axis, also optical axis. So that's about the 2 typefaces. Now let me go to more derivative applications on top of the designs. Since I created SVGs, I had an idea that I can use the SVGs because I followed the writing direction. I can create an education website where I teach kids how to write a letter again. So I can animate the SVGs like this you're seeing in the screen, and I can pick any letter like this, and it will show you how the letter is drawn, because I have the SVGs for the background that is with a higher weight, and then the thinner version overlaid on top of it, so that I can teach, like you can learn how it is written. Not only that, you can also draw on top of it. If you're in a tablet or using mouse, you can draw, follow the path, and see how it is written. And you can also listen how it is pronounced with some examples and the example words, and also contains following that. So that was a derivative application, and surprisingly, I hear that there are a lot of users for these applications. People who wanted to learn the nature of the script is using this application these days. So that became like a derivative application on top of the SVGs that I designed. All right. So now let me go to the lessons, the learnings from the whole explorations. The first lesson that I wanted to share, that I already illustrated, is the easy experimentation part. Uh, so with the immediate feedback loop and with the tooling, you can have easy experimentation. You can change the parameters, you can tweak the source code. It's immediately you can see. And if you design something and if you change your mind later, you don't need to redraw all of them. Provided you parameterized it earlier, you can get these kind of experiments. You can also have one version and then you can say use some version control on top of that, change something and see if it is working, revert some parameters. So it's like if you're familiar with the source code, like software engineering, which is my primary profession, this becomes a natural extension of my skills in software engineering. So that's the biggest skill, biggest extension of my skill that I achieved with this approach. The modularity is another part because every shape, every function, I can write like the functions, coroutines, about drawing few shapes. So this is almost same as like reusing the shapes that you are using in the GUI applications, right? So, but here instead of shapes, you are reusing the code, and then code can be like a functions which will take some parameters and then change the output accordingly. So you get the full control of the modularity, and in addition to that, if you use systems like Copilot, um, these days people use the AI assistants, which are very good in auto-completing the source code. You get the power of auto-completing the source code, but you are in full control of the source code. You are not asking an AI system to draw the shapes. You are asking an AI system to reuse some of the patterns you learned and write these equations, right? So you save that time also. Um, Another a big challenge that I noticed while working with this one, as an engineer, as a person who is keen to the mathematics, uh, there is a constant struggle between mathematical accuracy and the optical correctness, because I will try to make the equations elegant in terms of mathematics. So the half of a shape, half of the width means 0.5, right? Divided by half. But that's not the thing that you want in the application. You need to have optical correctness. So optical correctness is not really a mathematical thing. It is something that you need to prove it by not looking at one place, but like, you need to use a paragraph or a combination of strings to see if it is good to your eyes. So that's a struggle that you need to keep in your mind always, that nobody is looking at your mathematical accuracy or skills. People are going to look at how pleasing it for your eyes. This is a struggle, and it's hard to overcome, especially if you're rooted in engineering and mathematics. So that was a challenge. And then this nib-based design versus outline-oriented design. There are pros and cons to these both of these approaches. I have read a lot of debates whether how much you can achieve with this kind of putting a point and then using curves to connect with these curves, whether you can get good quality folds out of that. So yeah, good is relative. At the same time, what I found is that as long as you have a design in your mind, you can control the points, you can control the curves, because ultimately it is Bezier curves. The controlling the Bezier curves is completely in your hands. So just like instead of uh, uh, you know drawing a point and using the handles to adjust the curve shape on the on curve or the out curve points, this is same. Like you can use the Bezier curves in the same design and change until you are pleased with the design. So, and with the help of the modularity, you may not repeat that very often. You can parameterize it. It's about how clever you are, how modular you can design. It's up to your skills in mathematics. So that is one struggle I found. If you ask me, like, are you proposing this as a replacement for GUI-based design? Not at all. Like I said, this works for me, but doesn't mean that it will work for anybody, right? I open source the whole approach documented it. There might be software designers who are also typeface designers or typeface designers who has the programming skills, who can pick up this one and try it and see if it fits your needs. Then that's up to you. It's just a tool, so you pick the tool that is most comfortable with you. So that's all I wanted to present today. Thank you for listening.
Yeah. Any questions? Yes.
Yeah, just a quick one. I might have missed it, but yeah, sorry. What was the user interface that you showed in the presentation? Like, you developed the software as well, or was it GUI?
Yeah, so the software application that I used for my demos here, let me show you. One second. Here. This is just a web interface I created. Anybody can go and try it. It's online. It's a sandbox application for you can do a quick demo of these kinds of things. It's just like a CodePen or JS Fiddle or that kind of applications. You go to the website, you change the code, you get a switch. So this is for easy experimentation and sharing your concepts, designs. This is not the one I used in my typeface design. I used the VS Code IDE, and VS Code has the SVG preview feature, right? You can change the source code output. You can see it in the another tab, and you don't need an extra IDE for that one, because it's basically create a meta post. You can have an auto save action for the source code. You get the SVG. VS Code will automatically refresh the SVG for you, and that's all the tooling you need. You don't need any GUI. But of course, for proofing, you are not seeing a single glyph at a time, right? You need to have various springs testing setup. For that also, I built a simple website, like a proofing website, where you can control the axis and see it. So I didn't use any font designer IDE. I just used my favorite coding IDE, that is VS Code.
You have a question? I have a suggestion. So in your architecture, you're only using MetaPost, but you can parallelly use Metafont to get the best hints, because in the good old times, hinting was a very important issue. Now, perhaps today with the high resolution screens, it's not important anymore, but in the good times, Metafont was very good at producing hint information.
Yeah, thank you. Yeah, that's accurate. The primary script that I designed is Malayalam. It's a complex script. There is no hinting. I mean, you can hint it, but hinting that many glyphs, and it's not the worth the effort. So usually we don't hint the Malayalam fonts. It's also a little bit dense, and seeing that in 8-point or 5-point is useless. So we don't usually hint it. But you are completely accurate on like Latin-based hinting and metaphor. Thank you.
Okay. So no more questions. Thank you very much, Santhosh.
Thank you. Thank you for listening.